Well, this rather unexpected little challenge has come through. Peculiar in a sense. I've got some material in here to dummy up a male thread. I'll tell you why. The problem we've got is that my next door buddy, he's got a faucet on the bath and he wants to modify that to extend for a shower as well. But the interesting thing is, to save taking the whole thing apart totally, sticking out from the tub is a spigot which is about 2 inches long, something like that. And what we've got to do is to make a female thread that will allow him to go onto that and then convert from that to, I think at the moment we're thinking 3/4 pipe, copper pipe OD. As the thread has to stay put on the bath, it seemed worth making a test thread first, and the reason this thread is slightly tricky is because when he measured initially and came in to see me about it, he said, oh, it's I don't know, he had a vernier, it was like 26.5 mil, and he assessed it at 1.25 pitch, assuming it was metric. So in the end I went round and did some more measuring, and the measurement doesn't seem to fit any ordinary pattern. The outside diameter is 1.058, which is just below 1 1/16. It's not quite 27mm. It doesn't really match anything. So it's 1058, and although it measured at this 1.25 pitch initially, but I thought, okay, 1.25, how does that equate to TPI? Well, leaving aside the 0.4, 1.25 into 25, let me just check to be quite sure. I don't know why I was even bothering to check again, but so the 1.25 apparent metric pitch equates to 20 TPI. Near as damn it. Put a 20 TPI thread gauge on it and it looked basically perfect. And I wasn't sure if I had the right change wheels anyway to try a metric thread on the lathe. Don't think I've even ever bothered to try, to be honest. So we're going to go for 20 TPI. This piece of stock here is 32 mil, which is 1.258. So we're going to turn that down to 1.058, and we'll have to bore it out a bit because the spout on this faucet has what you can imagine is an end piece with a seal. I forget whether it's an O-ring, which goes into the spigot, and then there's a collar, tightening down collar, and that's what uses this weird thread. Somebody might say it's a standard thread, but not, to me it isn't. So we're just going to prep this, turn it down, bore it out, and then we'll cut an experimental thread. And as soon as I get a chance to try it on his thing, which will probably be later today or tomorrow, but we're going to hopefully save time by putting time into making a dummy thread. And I've got this piece of brass, which, if I remember rightly, I'm not quite sure whether this was a piece I made for my rotary table to be able to set up my large carbon brushes. But this piece, which otherwise is just surplus to requirements, I think I can probably use that. But anyway, rather than waste it and get the thread wrong, because I can't test the female thread till I take it through to his bathroom. Alright, let's see where we go. I've just taken a 20 thou cut. This isn't absolutely on centre, this old chuck, usual problem. It was only running out by about 3 thou, but anyway, that's the first cut. And I've actually got to take, interestingly enough, exactly 100 thou off the diameter. So I'm going to take it down, I'll probably go 20 thou approximately for a few cuts, and then check it when we get nearer. I'm taking still the lightish cuts but heavy feed. In theory I've got 20 thou left. We'll see how it works out, see what I've got left with a check measurement. I didn't show you actually previously this old Lufkin mic hasn't got a ratchet. It's accurate enough, but not the easiest mic to use. Obviously I faced and centre drilled, I didn't bother you with that. Let's check this out. It looks like we've got 49 thou to go, so I'm going to take another 20 and then check again. I'm going all the way down here the same, but I'll make a thread relief groove about 1 inch in for the test thread. Check that again. It's funny how you get used to certain mics, and I suppose 0 to 1 inch is the most used. Just another excuse me, 3 thou plus. I haven't got my air on at the moment, so it's chip brush time. Let's see what I got. Just about there, I think. I'm doing the usual trick, using a parting tool, but spindle in handle in spindle. You just hand feed to get my relief. This is a fine thread, 20 TPI, so just give a bit of relief so we can get out of the back while we're cutting. I don't think we need all that much, but I'll make it fairly generous so we can get a good escape from the tool. In fact, I'll probably thread it by hand. Well, it depends, and see how I feel. That's a pretty generous relief, so I think that'll do. I'm just using a 1, 2, 3 block to set my threading tool square. That'll work. And then set up the gearbox. Right, I put a chamfer on there. We've got the back relief. This is the part of the faucet which we're interested in, and if you can see, there's a ring of thread just about in here, and it's only, I'm just counting, 1, 2, 3, probably only about 4 turns, but for this adapter we're going to probably go deeper than that. There's actually an inch, just under an inch of thread on the main spigot, so this thread should allow me to do a test on what I'm cutting on here. So I'm setting up for the I think I'll put the back gear in, play safe. You probably won't see the dial very easily, always get reflection, and it's not quite perpendicular to that face, but it's a minor amount, and I've got to clear the live center. So I'm going to try a scratch test and see what happens. Let's take a look at that. This is the 20 TPI. That's spot on, and out of interest, let's look at the 1.25 metric. And that is as close as shouldn't matter. See a very slight discrepancy, but I think if we make this not too tight we may be alright. So I'm going to take a few more passes. Judging by the ID on this piece, the thread in there, the ID suggests we need a 20 thou thread depth. I've moved the indicator back slightly so you can see here, although I'm not necessarily far enough in. Let's try that. This should take me up to 11 thou in theory. It's coming on. I've got this new carbide 60-degree threading cutter, so I'm not using any oil. I can see what I'm doing relatively better. The thing I can't see is my damn dial. It's hard to see the figures on it. Alright, let me get a bit further down on here. I've got taking 1 thou cuts now, more or less. Well, my ID measurement in here may not have been quite as accurate as I thought. I'm going on way beyond 20 here. What I'm looking at is the crest, and we want this to be, if anything, a little bit slack as against tight. So I'm going to take another 1 thou pass on there and then see what's what. Well, I don't really expect this to fit, but as yet I've still got some marker on the crests here. This is trial and error. That's one reason I want to make this test piece. It's starting. Just tight. So I think what we'll do is we'll dress that with a file and mark it up again and cut a little bit deeper. And we get that marked up again. Alright, I've re-zeroed the dial because I'm not going to, all I want to do here is keep track of my depth of cut. So I'm just going to take a thou at a time and see how the crest looks. I've only taken a smidgen off with the file. Let's have a look at that. I think for depth I can probably go until the crests are not really showing much, because I say this is going to have to be allowing for a slightly slack fit and not tight. Although I suppose let's just see where we actually are. Might be an idea just in case. It's trial and error, this sort of thing. It's going on, so we'll take another thou. Suck it and see. Try again. I still can't work this thread out because it just, so far as I can tell, doesn't match anything. Not in the book anyway. There we are. I think that's probably about it. 1, 2, 3, and then it's going a bit tight. Of course there is the possibility that if this is a metric pitch that we're getting into slight trouble with the pitch. So I think the answer is, hoping that it'll be adequate, we'll take this thread down a smidgen more, so that's a looser fit and that might give us the leeway. Well, I took another bit of cut and I think we're probably alright. If I make the if I make this that was the old mark. Alright, let's make that mark a bit bigger. If it's visible, yes it is. This is now decidedly undersized by a good couple of thou probably. 1, 2, 3, 4, 5, 6. Oh, then we're bottoming out behind the thread in here. Well, that's 6 turns, and I've got enough slop there that I think if I use that as my pattern when I cut the female thread and get it reasonably slack. It does seem, when I looked at the pitch gauge, that although this approximates 1.25, you can see is a fractional difference, therefore the reason for making it making this undersize, and which is what we'll do with the hopefully the brass. So it's as far as we can go on that bit for now. This will incidentally, when everything's fitted up, have some pipe tape, PTFE, Teflon tape for sealing, so again being slightly slack is desirable. One thing I don't remember for sure when I made this piece, which I think I said earlier was for testing on my little rotary table, not rotary table, my turntable, right, my powered turntable, mainly for welding. So as I've got to bore this through and through, I thought I'd better use the 4-jaw, set it up for this bore. We're now less than half a thou. This is my metric dial indicator, and it's showing about 0.01, which is just under half a thou. It's about as good as I can get. So I'm not sure what size the bore is on here. I'll see if I can enlarge that. Let's just see roughly what we've got. 5/8. So I've got to go through on 5/8, which should be about right for the rear here, which is going to eventually be turned down. That rear's got to have about 25 thou taken off to get to 875 for the copper pipe outside diameter equivalent. So that'll be okay. So if I go through with 5/8 the rest of the way, in fact this end doesn't need to be so darned long, thinking about it, but I'll get through with 5/8 through here and a bit more, and then probably do that with a boring bar. This is not the best of drills actually, I must get another 5/8. Anyway, we've got an inch start and I want to go 2.5 or almost really, get through to here, and once we've done that, bore out, turn this just to tidy it up, probably put this in the mill and put a couple of flats on for a wrench, if there's enough wall thickness that is, otherwise it'll be a strap wrench to fit it, and then we'll turn it round and finish off this end. How to use a piece of semi-scrap. You can see what a terrible grind it's got, but this first inch is giving it a guide, and fortunately it's not that critical. So I'm going to carry on and get through to 2.5 inch. I've just taken a quick pass down there. I'm going plus on an inch so we can make a end of thread relief at the back end later. And that is what we're aiming for. Alright, it'll leave wall thickness of about 1/8, well over 1/8, but there's a lot of material to come out. So I'm going to press on with that, probably tomorrow now actually. It's time to refresh and get some rest. So get back on this soon. Well, there's a lot here that didn't get videoed. because the guy who wanted the job done has been with me whilst I was machining. This side's been bored out and threaded. This at the moment, you see how rough that 5/8 drill was. Anyway, this at the moment represents a spigot, the diameter of copper pipe, which at the moment actually is, I think, the way we're going to go, but there was thought of putting a thread on it, but to set up for a taper thread is a bit of a pain. I'll just take this out a minute and show you, because I might put it back in. So there's the piece. Sorry I didn't show the threading, I just had to get on with it. And there's my dummy male thread. And despite the theoretical pitch discrepancy, we're good to go. I've made this slightly oversized, hoping it'll go on the spigot on the tub, with enough room for a bit of PTFE Teflon tape. So, a somewhat abridged video. Anyway, you can see what we've done there. We went right the way through with the 5/8. And now the question is what we do here. So I'll put it back in the forge jaw, because we've still got to decide. I might come back video wise, it depends. If I'm tied up with somebody here, it's not so easy. Okay guys, that was meant to be a bit more detailed on the threading side, but my buddy next door was here all the time and I was just busy doing the work on it. So from the end of the, not the previous clip, one before, we continued boring that out. We actually took it to about 10 thou plus, I think, just to give me plenty of scope, and cut the thread to where we wanted, or where it was supposed to be, plus some. So in the end that male sample piece went in real nice, and the piece is now over in his house. It's screwed onto the tub spigot, just beautiful. Just enough freedom in it to get some pipe tape. What he does from that's another matter. He's going to probably get a 3/4 inch compression T, which will split for bath supply and shower head. I'm not sure what's going to happen about a valve, that's another factor. Anyway, you get the drift of what I did with it. It was just such a weird thread, which I described in some detail before. So anyway, we'll probably put this up just as a little bit of interest, particularly having to cut a male thread first, which seemed a logical way. Alright, so that's it for now. Whatever's next, I have no idea. Alright, bye for now. Thanks for watching.